Hello, and welcome back to EEforEveryone, Part 7 of the Timelapse project. Today is going to be a very exciting day. We're finally going to assemble a PCB. Now, this will be the PCB that functions as the control board for our Timelapse project. As always, I wish I had enough time to explain each step of this process in extreme detail, but there just isn't enough time in each video. If you'd like more of a soldering tutorial, let me know down in the description or on Twitter at EEforEveryone. The window vent is installed, the fan is running, let's do this. The first step of this process was to 3D print a small spacer that will let us align the display module with the front of the enclosure perfectly, and will allow us to solder that together over here and then slot it into the final assembly. It'll help to keep the gap between the display and the front of the case as small as possible. So, we've got some parts, we've got some boards, and we've got some time. Let's get started, and let's do this. There was one time, it's my senior project, we had developed a board which was meant as like a prototype run for a medical device, and we spent hours and hours and hours designing these boards and researching microcontrollers and learning about, well, I had implemented Arduinos on a separate PCB before, so I knew how those worked, but we wanted to use a new type of part as a learning exercise, challenge ourselves, so to speak. And so we were using a TI microcontroller, which was programmed via JTAG, and that microcontroller was awesome. Quite frankly, it was as easy to implement as an Arduino as far as the physical board implementation. It's just JTAG programmer instead of the Arduino's ISP, which in some ways was even better. I mean, the JTAG was even better in some ways. But we had this strange issue where, we would connect it to the computer, it would work well, we'd get it working, and then we'd go to program it, and it would work fine, and then we could never talk to it again. And I was like, what the heck? Like, that's not how microcontrollers work. How in the world could this part work fine, no issues, and then just stop talking to us after we program? Like, what? We were using a TI programmer. It's actually cut off from one of their launch pads, and we just couldn't figure out what was going on with that microcontroller. And after a long time of debugging, we realized the solder had wicked underneath one of these capacitors and bridged across, shorting out one side of the crystal. Turns out, crystals don't oscillate so well when they're shorted. Who would have thought? looks like all the resistors, diodes, and whatnot are soldered into place. Backup battery, programming headers. All that's left is the display. Which brings me back to my point before about making a mistake. I forgot to order one of those displays. So I guess I'll just kind of show you here, as you've probably seen throughout the whole process. I was referencing this for crystal orientation. It's got this, let's see, come on, focus. Yeah, okay, so you can see that spacer in there. It's got, looks a lot like this one. It's got these little nubs that poke into the display. It's in this orientation, and then the pin header pokes right through to this side of the board and gets soldered in place. So this maintains spacing, and it goes right here. Gives enough clearance for those solder pins, but you wouldn't be able to solder it in after the fact. So basically, you put this in the display, put your display in here, and you take one of these front panel pieces and you line it up, and that'll hold the display in the right spot. And then you come in here, you tack solder this in the correct orientation, verify your buttons all work and all that. I've had some issues where there's not enough clearance on the buttonholes. I'm gonna have to update that in the model. But yeah. So that's how that gets soldered together. For right now, I'm just gonna try to do some movie magic here, and you know what I just realized? I soldered this pin header in backwards. That is on the wrong side of the board. And that is going to be a bear to get off because it's got so many pins. I think I've got a spare. So I think... Oh, that's a pain. Everything about that's going to be a pain. Oh, yeah. I should have been more careful. Well, you know what they say. Measure twice, cut once. Or in my case, measure nonce, cut 4 times. You know what? I need to go buy some solder wick to fix this. There's not a chance. I could get out the hot air gun, but I'd melt the thing to bits, so you know what? I'll fix this in my own time. That's going to be a pain. In fact, I might just assemble a whole nother board just to not fix this connector, because I've got 10 of these boards. So... Nope, there you go. So we have our control board with all of the components installed. Awesome. And it fits perfectly into the front panel of this enclosure. The buttons poke through the front panel. There's a minimal gap between the display and this front panel piece. You can still press the buttons once it's installed. Works great. Unfortunately, the board that we actually made today, I forgot to order the display, and this connector is soldered in backwards, which isn't exactly ideal, but you know, it still fits, which I guess is nice. In reality, what I'm probably going to use this board for is a display module. There's one of the LED boards that has some channels burnt out due to a design defect that we'll talk about in a future video, and this control board is going to go into that display unit, which doesn't really need to fit into an enclosure properly. Regardless of how the actual soldering we did today turned out, I was a little distracted by the filming and just how everything was coming together, but I had a lot of fun creating this control board with you, and I really love how quickly it can be assembled. There's only 9 or 10 parts in the whole board, and it eliminates a lot of the tedium that usually comes from assembly, which is needing to switch between all of the bags of parts. At least that's the tedious part for me. So only 8 or 9 parts in the whole design, goes together like a breeze. The source code for this part of the project, not the CAD since it's not finished yet, but for the actual plant light control board, will be available in the description of this video. In the next video, we'll discuss the programming that was done to bring this control board to life, and how we used the different libraries available to actually put this together. I hope that you feel inspired to create your own PCB, integrate your own microcontroller, and solve a problem. And most of all, I hope that you learned something great today, and I hope to see you again soon. Bye!